Alright, today we're going to be looking at how to graph linear and absolute value inequalities. So yesterday we were graphing equations, today we are graphing inequalities. So first we're going to be solving for y and graphing the boundary. And then we're going to use a table to determine the shading and type of boundary. And we can use a test point that can justify our shading. So if you take a look at the table we have below here, this will show you which symbol will for which type of boundary and shading. So you have the line underneath the symbol, that means a solid boundary, and your line will look like this, and the boundary solid. And if you see it like this without the symbol underneath, without the line underneath, you're looking at a dashed boundary like this. For the shading, if the symbol is opening towards the right, you shade below, so down under the line. And if the symbol is opening towards the left, you shade above the line. Okay? So not only do we need to know how to graph it, we now need to use the symbol to show us how to shade it. Alright, so let's take a look at this. This is just a regular line. This is going to be a line. However, it's not in slope-intercept form. It's not solved for y, so we need to do that. So we need to get this y by itself. The x needs to go to the other side, so we're going to subtract x. And that will leave us with negative 2y less than or equal to negative x plus 4. We still need to solve this for y, so we divide by negative 2. Now one thing to keep in mind that you'll remember from inequalities is that when you divide by a negative number, the symbol flips around. Okay, so this symbol is going to flip around, and I'm going to have y is greater than two negatives, so this is x over 2, or 1/2 x. Remember, there's a 1 here. The reason I'm putting the 1/2 is so that I have the actual slope, so 1/2 x. And then 4 over negative 2 is negative 2. Alright, so our line that we're going to graph is right here. And we have a slope of 1/2. And we have a y-intercept of 0, negative 2. And then for the shading, the symbol is opening towards the left, and it's got a line under it. So this will be a solid boundary shaded above. Put that over here, solid above. So if you look back on the table, remember, if it's opening towards the left, so we're looking at this symbol right here, left line, solid boundary shaded above. Open left, line under, solid, shaded above. Okay, with all this information, we are now ready to put the graph together. Alright, so my y-intercept is 0, negative 2, that's right here. My slope is 1/2, so up 1 over 2. It's positive, so my line should point up. I could also go down 1 and over 2, as long as my line points up. Whoops. So I'm going to connect these, and I'm going to connect it as a solid line because of the line underneath. Alright, so I'm going to connect it as a solid line, just like this. And then the shading, I'm going to shade it above. So should be shaded. Everything above the line should be shaded. So I'm going to shade it like this. Make sure everything above the line is shaded. And what that means is everything in the shaded area is a solution to the original equation, x minus 2y less than or equal to 4. And I can test a point in this shaded area to make sure that it's a solution to this equation. So let me pick a point in the shaded area. An easy point to pick is going to be the ordered pair 0, 0. It's in the shaded area. It should be a solution to this. I'm going to plug in 0 for x and 0 for y. So I'm going to have 0 minus 2 times 0 less than or equal to 4. 0 minus 0 is 0. 0 is less than or equal to 4. And that's true. 0 is less than or equal to 4. So 0, 0 should be a solution, and it is. It's in the shaded area, so it is a solution to my original equation. Now you'll recognize this type. This is an absolute value function. Alright, so we need to graph this like an absolute value function, except we just need to change one thing, which is the inequality. And we see this is opening towards the right, so that means it is shaded and it has no line under it. So when we get to the graphing part, this will be a dotted line and it will be shaded below. Alright, so if we remember how to do this, the vertex is 2, 1. So 2, 1 is going to go in the middle. And then we're going to do 2x values smaller, so 1 and 0, and then 2x values larger, so 2, 3, and then 4. The table should be in order, 0, 1, 2, 3, 4. Alright, so I'm going to plug each of these in and evaluate for y. So I'm going to plug in, and I don't have to use this symbol. When I'm plugging in to get points on my table, I'm going to use an equal symbol because I want to know that it's on the actual line. It's going to help me graph the line. So I'm going to plug in 0. So 0 minus 2 plus 1. 0 minus 2 is negative 2. And the absolute value of negative 2 is positive 2. So when I plug in 0, or when I substitute 0 in for x, I get 3. Alright, let me try 1. So y is equal to 1 minus 2 plus 1. 1 minus 2 is negative 1. Absolute value of negative 1 is 1. And 1 plus 1 is 2. And if you had not noticed the pattern with the absolute value functions yet, after the vertex, they go back to the same one. So if this is 2, this one's 2, and if this one's 3, this one's 3. Because remember, it's a V-shaped. So those are going to be the same as these two. Alright, let me actually graph it now. Let's graph the points. So 0, 3 is right here. 1, 2. 2, 1. 3, 2. And 4, 3. Now, the thing about this one is it's going to be a dashed line, or a dotted line. Dashed or dotted, however you want to say it, because there is no line under it. So it's going to be dashed like this. It's also going to be shaded, alright, and it's going to be shaded below the line. It'll be shaded down here. And we need to make sure everything gets shaded, okay? Everything down here gets shaded, okay? So my solution area is everything that I've covered in orange. That's my solution area. The dots on the line tell us that those are not actually solutions. Alright, even though I found this from my table, it's not an actual solution to this graph. And just for good measure, let me check an ordered pair. I'm going to check the ordered pair 0, 0 to see if it is indeed a solution. So 0 less than absolute value of 0 minus 2 plus 1. So 0 is less than absolute value of negative 2 plus 1. So 0 is less than 2 plus 1. 0 is less than 3. That is correct. This is in the right area, so I've shaded the correct region. Okay, if you have additional questions on this or how to do this one, just refer to the resources page. They go over more problems for that.